Why change from a lead-acid battery to a lithium battery? This question is certainly the most frequently asked, and is the first of a long list. I will explain from the following aspects. First, charging the battery. For lead-acid battery, the charging efficiency of this type of battery is low, only 75%. A lead-acid battery needs more energy for recharging than it delivers. The excess energy is used for gasification and for mixing the acid internally. This process warms up the battery and evaporates the water inside, which results in the need to top up the battery with distilled water. Lead-acid recharging has severe limitations, and a number of critical points. Here are the most important ones. First, fast or partial charges ruin a lead-acid battery. Second, charging times are long, from 6 to 8 hours. Third, the charger does not collect full information on the battery. It only checks the voltage, and that is not enough. Changes in temperature affect the recharge profile, so if the temperature is not measured, the battery will never charge completely in winter and will gasify too much in summer. An incorrect charger or setting reduces battery life. Fourth, poor maintenance will also reduce battery life. For lithium-ion battery, it can be fast charged to 100% of capacity. A lithium battery saves on your electric bill, as it is up to 96% efficient and accepts both partial and rapid charging. Second, weight of battery. For lead-acid battery, the weight of 1 kWh is around 30 kg, but for lithium-ion battery, the weight of 1 kWh is around 6 kg. On average, lithium-ion batteries weight 5 times less than standard lead-acid battery. Third, maintenance. For lead-acid battery, high maintenance and systems costs. Ordinary maintenance is one of the greatest costs, as it includes topping up the water, maintaining the filling system, and removing oxide from the elements and terminals. It would be a serious mistake not to take into consideration 3 other hidden costs. First, it is infrastructure cost. Lead-acid batteries release gas while they are charging, and must therefore be charged in a dedicated area. Second, cost of gas disposal. The gas released by lead-acid batteries must not remain inside the charging area. It must be removed to the outside by special ventilation systems. Third, cost of water demineralization. In smaller companies, this cost can be included in ordinary maintenance, but becomes a separate expense for medium to large companies. Demineralization is a necessary treatment for water used to top up lead-acid batteries. For lithium-ion battery, no infrastructure cost, no gas and no need for water, which eliminates all additional costs. The battery just works. Fourth, service life. Lithium-ion batteries last 3-4 times longer than lead-acid batteries, without losing effectiveness over time. Fifth, safety, waterproofing and emissions. Lead-acid batteries have no safety devices, are not sealed, and release hydrogen during charging. In fact, their use in the food industry is not permitted. Lithium batteries release no emissions, are suitable for all applications and feature 3 different control systems that protect the battery. First, automatic disconnection, which disconnects the battery when the vehicle is idle, and protects the battery from improper use by customer. Second, balancing and management system, which maximizes battery efficiency. Third, remote control system with automatic warning of trouble, and malfunctions.